Okay, so there's several ways to define Antarctica. One way is the political method. Okay, the political method sets Antarctica at 60 degrees south. So that includes a lot of water as well. Essentially, that's the extent of the Antarctic Treaty. You'll be learning more about that. It's a marvelous piece of legislation that keeps Antarctica run by committee, essentially, a committee of countries. This chart here is an old map, an old relic, that shows how pre-treaty Antarctica was cut into slices, into wedges of pie, and different countries had different claims. So, for example, the place we're going to right now had overlapping claims between Argentina and Chile and Britain. When the treaty came into place, all that went to one side. All countries agreed to temporarily suspend their claims on these different places and areas. So Antarctica could be declared politically as anything 60 degrees south. We are now more than 60 degrees south, so by the political guideline, we are in Antarctica. Another way is through the geographic boundary of Antarctica. Now, most people would say, well, once you're on the land of Antarctica, doesn't that count? Well, what about the islands of Antarctica? Do they count? Absolutely, because an island is simply currently an island because of the current state of sea level. Sea level changes all the time. If sea level were to drop, you discover that those islands are in fact connected to the mainland. And also, Antarctica is confusing because it has a massive ice sheet that doubles in size during the winter time. Once you're on that ice sheet, are you in Antarctica? I would argue you are. The best way to define whether or not you're in Antarctica, for me as a biologist, is a biological boundary, an oceanographic boundary. So we do this through using a specific oceanographic event called the Antarctic Convergence. This is a very specific oceanographic phenomenon. You can't see it with your eyes, but boy, can you feel it. It has to do with currents and temperature. So I will be talking more about this in a different lecture, but if you have a look at this chart here, this is all the currents that we have in the world. So you can see in the southern hemisphere we have these large currents called gyres that go around the entire basin, but at the bottom we have one current that goes all the way around the world like a giant cog of water. This is called the Antarctic Circumpolar Current. And as a result of that, you can see it quite easily in these color-enhanced satellite images. You've been seeing some of these on our iPads. If you come up onto deck and you ask to see some of these charts, we have these available to you in real time. So this one is for wind strengths. By the way, that's what we just had. That was the storm right there. So we're now down here somewhere. And you can see that there's a general sort of circular pattern to the winds in that area. That helps drive that Antarctic Circumpolar Current. Here's a similar chart. Now we're looking at currents, which are being driven by the winds, and also temperature. So red is hot, blue is cold. See how there's a really distinct boundary here where all of a sudden the water gets really, really cold. Now, it turns out that if you were to look at this three-dimensionally, you can see the same thing. This is a cross-section of the Atlantic Basin. This is Antarctica. This is up towards the Arctic. The equator is here roughly somewhere. And what we have here is, again, color-coded. Purple is what us scientists call jolly cold. This is medium cold. This is, and then red is, You're not going to get any water unless you're having your shower for the next couple of weeks. So you see here very distinct boundaries. It's not so much that we have a specific color, it's how quickly it changes color. That indicates to us what we say in oceanography, a front, an oceanic front, which is a joining between two water masses. Three-dimensionally, this is what it looks like. This will be on the test at the end of the trip. I expect you to memorize it all. Essentially, you have to think three-dimensionally. It's like water folding upon itself. Okay, so in the Antarctic coastline, which is here, you've got this really, really cold water coming down, sinking down below warmer water coming up from above, and so on. And here is the Antarctic Convergence, essentially layers of different temperature and salinity waters. These fronts are essential because they help keep the biology in. Plankton can't pass these fronts because they represent rapid changes in density. The best way to see it for us, because you can't actually see it physically, is to take temperatures. So we use temperatures from the engine coolant to monitor air temperature and also water temperature. The blue line is water temperature, the orange line is air temperature, and you can see how it goes along and then it drops very suddenly right here and right here around about, this was about midnight last night, we passed the convergence. And at that point, we were in Antarctica. Of course, we were all asleep. Or maybe watching The Magician, one of the two. When you get there, when you get to the convergence, and we have passed it at this point, what do we see? We see reduced visibility. There's some fog associated with the convergence because cold water brings down the dew point of the air, and so you have fog. You start to see a lot more animals. How about those fin whales? Wow, right? Probably 100 to 200 animals in the past 8 hours or so, and you get quite a dramatic drop in temperature, which I'm sure you've all felt. So that is technically what you see at the convergence, right there. Absolutely nothing because it's foggy. However, it was at night, so that's what you saw when you saw the convergence. Okay, that's it from me. I'll now introduce Rachel.